Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistance, and today we are discussing Dalton's Law of Partial Pressures. Our first question comes with a mixture of gas contains 6.44 moles of helium, 0.47 moles of neon, 1.52 moles of argon. Calculate the partial pressures of each gas when the total pressure is 3.00 atmospheres. So we're going to begin by calculating the total number of moles. Edit. So we're going to begin by calculating the total number of moles. We'll denote it as N sub T. And that's simply the sum of the moles of the diverse species. So 6.44 moles plus 0.47 moles plus 1.52 moles. And their sum comes to be 8.43 moles. Once we've done that, we can then use that total moles to determine what each species mole fraction is. In other words, what portion of the total gas is any given species. And we'll denote it as X sub whatever the species is. So for the first one, it's X sub helium. And that's going to be the moles of helium over the total moles, which is equal to 6.44 moles over 8.43 moles. And if you do the arithmetic out, you find that it's 0.764. Note that a mole fraction is a unitless figure. So X sub Ne for neon is equal to the moles of neon over the total moles, which is equal to 0.47 moles over 8.43 moles. And our mole fraction turns out to be 0.0558. Then our X sub AR for argon is N sub AR over N sub T, which is equal to 1.52 moles over 8.43 moles. And that gets us a mole fraction of 0.180. Then in order to find out the partial pressure for any given gas, we simply multiply the mole fraction by the total pressure. So our pressure for helium, in other words, the pressure exerted by helium, is simply the total pressure, which is 3 atmospheres, times its the mole fraction for helium, which was 0.764. And that gets us 2.29 atmospheres. The partial pressure for neon is the total pressure, 3.00 atmospheres, times its mole fraction, 0.0558, which is equal to 0.167 atmospheres. And finally, our pressure for argon is equal to the total pressure, 3.00 atmospheres, times 0.180, the mole fraction for argon, and that yields 0.540 atmospheres. So those are the respective partial pressures for each species in the gas. Second problem states there is a gas sample composed of nitrogen, oxygen, and the atmospheric pressure of 726 millimeters of mercury. The pressure of the oxygen is 24.2 millimeters of mercury. What is the pressure exerted by nitrogen? This is, again, part of Dalton's law of partial pressures, where PT, our total pressure, is equal to the sum of each individual pressure. So in this case, it's going to be PT is equal to Pn plus PO. Now we know what the total pressure is. We can write that over here. PT is equal to 726 millimeters of mercury. And we know what the pressure on oxygen is, which is equal to 24.2 millimeters of mercury. So all we're going to do is solve for P sub n. So P sub n is equal to P sub T minus P sub O, which is going to be 726 millimeters of mercury minus 24.2 millimeters of mercury which equals 701.8 millimeters of mercury.